Hi Juan, just thought I'd do a little bit more of a detailed video about this soft start circuit that I'm creating here. You might be interested, just give you a little bit more look, a little bit more information. Um, yeah, so basically what I wanted to do is make a circuit where when I push my on button over here, um, it obviously triggers the relay, but what I wanted to do is only light up the LED if the actual relay physically triggers. So, for instance, if I disconnect the relay here and actually push the button, like this is simulating pushing the on button, you'll see that the standby light will go out, but the power light doesn't come on because the relay hasn't actually triggered. So the standby light's going on, it's not going on, so you know that there's something wrong. So when the relay is connected, like this, the relay is now connected. Now when I push the button, the standby light will go out just here in the red, and the LED that's built into the power button comes on. So then you know that it's actually triggered for sure. So what I've got here is just my AC input here, rectifier. So it'll be 12 volts coming in, AC, similar to what is used on the speaker protection boards. Then I've got my rectifier for 12 volts. That's just powering the rest of the circuit. And then if I give you a look on the circuit diagram here, you can see this is like the switch at the moment, it's open. So when it's open, the power runs down through here. This is a little bit of a similar circuit to what we used on the secondary power supply board. So this would be like when the fuse was blown and the light was on. So it's a very similar little circuit there that I sort of pinched from there. And then when the switch is closed, it turns on the one side of the optocoupler, and that shines the light onto the other side of the optocoupler, which then starts to activate the rest of the circuit. And what it basically does is it turns on this transistor here, which draws some current down through here, which then turns on this as an N-channel MOSFET. And it is, this is the N-channel MOSFET there. It's a BS 170 N-channel MOSFET. And yeah, so that's what this component is here. And I'm also using it here. So this is where the LED is coming on. It's actually a 12 volt LED. So it's going from here to ground and is getting switched on by this here. And this Zener diode is just providing the gate of this N-channel MOSFET with the right amount of voltage to turn on fully. So, and the same thing's happening over here. And this is what triggers the actual relay. This is just my protection diode for the relay, and then the relay comes on, and then what it's going to do, it's just going to bridge these two together, which is the relay, and this is where my 240 is going to be sitting here waiting to then go into the rest of the soft start circuit. So yeah, so that's sort of the circuit and what's going on. So you can see here, let me just grab a screwdriver. This is the little optocoupler here. This little thing here is the optocoupler, and then we've got one of the diodes here. Another diode. I think this one here is the you can see here with the Zener diode. So this must be the N-channel MOSFET, and this is the other diode. So that's the other N-channel MOSFET. And yeah, so that's it. It's just seemed to be a fairly simple circuit, and it seems to work quite well. And push this button. See the relay switches, and immediately the LED comes on because it detects that it's switched. And it does that by, when the relay switches, a current will flow down through here, and because it flows down through here, and you've got this diode here, it'll put 0.7 volts here, which is enough to turn on this transistor here, which then triggers the rest of the circuit to turn on this LED. And you notice that the current on all these other parts of the circuit which aren't actually drawing the current are very, very low. Like you've got picoamps here. Oh, hang on, that's before I've switched it on. So that's in the standby state, and then once I've switched it on, this is the on mode. So this is on mode. So once you've switched it on, this is your power button here. You can see here you've got about 3 milliamps here, half a milliamp there, 1 milliamp here, and 0.5 milliamp there, and 3 milliamps there. So it's basically drawing really no power at all. And when that's on, this is the optocoupler here. That LED comes on. It's drawing about 10 milliamps to turn the optocoupler on. But this is nothing anymore. This is turned off as nanoamps, which is obviously nothing. And yeah, so that's the circuit. I just thought I might give you a little bit more information about it. Yeah, because it's I know it's something that may be of interest to you. Anyway, once again, really good to hear from you again, and I hope you enjoy this video.